Whales, dogs, mice, chimpanzees, parrots, octopi. These 6 animals, and many others, have garnered reputations for their intelligence. Whales have complex societies, where they work together and appear to communicate over long distances. Dogs learn a variety of commands and skills, and work closely with humans in many ways. Mice are the animals of choice in scientific experimentation, in part because of their curiosity and problem-solving abilities. We put them through mazes because they're good at solving mazes. Chimpanzees might be our closest living ancestors, and our closest rivals in terms of cognitive ability. Parrots can mimic and understand human languages. They form close interpersonal bonds and continue to learn over lifespans that exceed those of humans. And octopi have evolved to use tools, selectively kill threats, and even camouflage themselves using their brain power. Like this. You can find developed brains that swim in the ocean or walk on land, from animals small as a mouse or large as a blue whale. What does it tell us that such a wide variety of animals display intelligence? One interesting facet of this discussion deals with genetics. Now, some intelligent animals, such as chimpanzees, are very close to humans in terms of DNA. But what about all these other animals? The birds, rodents, cetaceans, and even mollusks that display considerable abilities not found in most animals. Modern mice, for example, came from a separate line from the rodents that would evolve into early primates, a divergence that happened at least 100 million years ago. Whales and dolphins came from a separate mammalian line as well, one that spurned the land altogether and went back into the sea. To find our evolutionary link to parrots, we have to go even further back, as birds evolved from a separate line of reptiles. And our latest common ancestor with octopi? We're talking about some really basic creatures for which we have no fossil record and scientists can only postulate about. So what does this tell us? That we find intelligence spread around to such far-flung branches of the evolutionary tree. Well, for one thing, it hints that there isn't much in terms of necessary factors when it comes to intelligence. Being warm-blooded seems to help, but octopi are the exception that proves this isn't a rule. If so many different types of animals can develop intelligence in so many different types of environments here on Earth, maybe life on other planets has a good chance of doing the same. That is, if there is life on other planets and it's anything at all like life on Earth, it's fun to think about at least. But when looking at all these intelligent animals, we see something else, something that separates us from most of them. Look at how little of this evolutionary chart is dedicated to us and our nearest ancestors. Think of the speed with which modern primate species evolved, with our bigger brains and increasing capabilities, our cities and empires and magical technologies, our ability to create and to destroy. Think of how far humanity has come in just 100,000 years relative to the millions of years evolution normally works with. So while other animals have developed many advanced characteristics, tool use, teamwork, interpersonal affection, problem solving, communication, and maybe language, none of them have come close to dominating or changing the world the way we do. Whatever magical cocktail led to this cascade of complexity and control, it seems unique to us. In that way, we're still very much separate, very much alone. But I'm curious what you think. What can we learn from looking at the diversity of intelligent animals? And do you think humankind really is separate in this regard? And if so, what led to the separation? Thank you for watching.